Hello everyone, I'm Liang Haibing from Tencent Cloud. Today I'd like to share with you all about EdgeOne Edge Security Protection. My presentation includes 3 parts. The first part will discuss the current security challenges and the limitations we face in addressing them. In the second part, we'll explore how EdgeOne can address these issues. In the final part, I'll share with you solutions on the gaming industry. With the development of the internet starting from the 1990s to present, the evolution of cybersecurity can be divided into 3 stages. In the 1990s, when the internet was still in its infancy, many infrastructures and operating systems were exposed to public networks. In those days, web application deployment was uncommon. As a result, attacks primarily focused on the network layer and operating systems. The main threats were DDoS attacks and exploits targeting vulnerabilities within operating systems. At that time, the main defense methods relied on DDoS traffic scrubbing hardware and traditional firewall devices. With the widespread adoption of web application in 2000, we saw a significant increase in the usage of HTTP 1.0 and 2.0 on the internet. At the time, many infrastructures were exposed to public networks. At that time, cyber attacks primarily targeted web applications and infrastructures. During this stage, we enhanced web protection by introducing Cloud WAF services. At the time, due to the limitations of our on-premise security devices, we launched Cloud Anti-DDoS services. This stage lasted until around 2010. In the third stage, with the rapid growth of the internet, many applications were implemented based on API calls. At the time, our business infrastructures were divided into web application infrastructure and APIs. Consequently, the network's attacks we face are also diversified, targeting our applications in various ways. For example, DDoS attacks at the network layer, web attacks or vulnerability exploits at the application layer, attacks on the operating system level, and attacks aimed at APIs. At this point, a challenge arises where the same application faces various threat risks across different layers, making it susceptible to a mix of attacks. How can we address this issue with a single product? In the context of various attacks, we just mentioned all network defenses rely on the network. Therefore, our initial focus is on the pursuit of a faster network speed. We address this primarily through CDN and ECDN, which are designed to accelerate network performance. However, they fall short in terms of security, including anti-DDoS protection and web defenses. Let's move on to the second aspect. In China, our current defense against DDoS attacks relies on products like Anti-DDoS Advanced, which provides robust protection capabilities, but a limited number of nodes, typically ranging from 1 to 3 nodes. Due to the sparse distribution of nodes and the large distance between them and the edge, there is an inherent latency in its performance. However, it is inadequate for web protection, addressing only DDoS issues. The third type is Cloud WAF products. They mainly address web vulnerabilities, bot attacks, and API protection, focusing on application layer defenses. While they effectively safeguard the application layer, they have limitations in anti-DDoS protection and performance. As we can see, each product seems to solve specific issues, but they all have their limitations. This makes it challenging for us to resolve the systemic security concerns mentioned earlier with a single product. As a result, we have introduced, and the industry has also developed, new solutions to deal with these complex security threats. What you see now is an overview of these solutions. To tackle such complex attacks, we currently employ a combination of multiple products to provide security and accelerated integrated services. For instance, the first approach involves a combination of Anti-DDoS Advanced and Cloud WAF. This means that before attackers or users access the original server, they first pass through Anti-DDoS Advanced for traffic rerouting. During this process, DDoS protection is implemented. Once the traffic is processed, it is then directed to our WAF for further web protection. Finally, the traffic is directed back to the original server. In this process, there are a couple of considerations. First, the traffic goes through 2 instances of reverse proxy. This leads to a loss of certain security features. Consequently, when it comes to the protection by Cloud WAF, the effectiveness of defense may be compromised. The second consideration is about performance. That is, any internet-based application should strive for optimal network performance. However, as mentioned earlier, due to the single-point deployment in this setup, we cannot achieve the same level of performance excellence as a CDN. The third consideration is cost. Since proxy protection is used twice, we incur double the cost, in addition to the cost of the original server, leading to nearly 3 times the internet bandwidth expense. This is especially a concern under high traffic conditions.
In addition to the solution combining anti-DOS, advanced, and WAF,
There's another approach that combines CDN and Cloud WAF, which is also a choice of some of our customers in the industry. This involves directing the domain to the CDN for network acceleration, followed by routing through the WAF for further web protection, and finally, back to the original server. The first issue with this approach is while the CDN accelerates the content delivery, the subsequent processing through the Cloud WAF, which acts as an intermediate node, can lead to performance degradation. The second issue is that the entire process lacks DDoS protection. In this case, if a DDoS attack occurs, the whole system is vulnerable. The third issue is cost. As mentioned, with 2 instances of reverse proxy, the cost is triple that of direct access to the original server. Therefore, as we can see, although we're trying to address complex attack issues by combining existing products, there are still many limitations in terms of effectiveness, cost, and performance. Considering the above, Tencent Cloud has introduced EdgeOne to address both acceleration and security. What does the EdgeOne architecture look like? Let's explore this question now. The diagram on the left shows the entire system architecture of EdgeOne. From top to bottom, it shows the access methods supported by the EdgeOne. The process is divided into the access layer, the intermediate layer, and the origin pull layer, and finally, the deployment locations of our business systems. At the access layer, EdgeOne adopts a new network deployment architecture different from traditional ones. We've implemented the new Anycast architecture. This architecture can be understood as leveraging a distributed defense system to combat distributed attacks. As we know, DDoS attacks are distributed network attacks. By employing a distributed defense approach, we can effectively prevent the high-volume, quick attacks. Additionally, we integrated all nodes across the world, including those in mainland China, and through BGP control directed our business traffic to the nearest nodes to achieve network access via optimal routes. The second layer is the intermediate layer. Once traffic passes through the access layer, we have essentially completed the business access and protection. At this point, we need to return to the original server. However, the distance from the edge nodes to the original server may span continents or even an entire ocean, reaching thousands of kilometers. During this process, acceleration technologies are required to ensure the quality and stability of the entire transmission process, with low latency and minimized packet loss and jitter. Therefore, during this process, network acceleration technologies are introduced to meet the latency requirement across continents. We'll discuss this later. The third is the origin pull layer. This means that after passing through the last EdgeOne node, traffic is routed back to the origin server. We ensure this by utilizing multiple routes to guarantee that traffic reaches the origin server via the shortest and most stable route. This ensures the quality and security of the entire chain and process. This is the entire architecture of EdgeOne. Let's start with the access layer. As mentioned earlier, first, all of our nodes are integrated through the Anycast architecture. This means that each node broadcasts the same IP to the internet. In this case, any attacker is targeting a single IP, and the protection capacity for this IP is very high. Second, we have an extensive node coverage. We rely on Tencent Cloud's global network of over 3,200 edge nodes, which serves as access points. In this case, our customers route the traffic to the closest node for protection, computing, and acceleration. In terms of ISP coverage, our 3,200 nodes are connected to multiple top-tier ISPs globally, ensuring optimal network quality across all regions. The third aspect is enhanced capabilities. Each of the nodes integrates components developed in-house by Tencent, such as Aegis Anti-DDoS, Menson, and Lego. During this process, within a single node, we achieve security interception and network acceleration, while offering edge computing capability. This is the deployment of our access layer. Next, we'll talk about the intermediate layer. As mentioned earlier, once the traffic enters the access layer, the intermediate layer comes into play between the access layer and the origin pull layer. During this stage, the focus is on optimizing network quality across the internet. We primarily employ 3 methods. First, there are multiple routes globally from one node to another. During this process, we use various detection methods to explore each route's connection latency, retransmission rates, and other metrics. Based on these metrics, we determine the optimal routes. Second, we calculate the metrics for the paths between nodes. For instance, there may be 20 routes from node A to node B. For each route, we utilize an overlay-based architecture to automatically learn, analyze, and establish different routes. This is a dynamic process based on our detection information. where we constantly adjust the optimal route to ensure the stability and reliability. The first two methods are about detection and intelligent routing for multiple routes. The third method involves the use of a proprietary protocol. Given the inherent limitations of the TCP protocol during the transmission process, we have introduced a proprietary protocol for optimizing TCP. By leveraging this proprietary protocol for transmission in the intermediate layer, we aim to mitigate the stability issues inherent in TCP to enhance its rates. The result of our optimization are evident. A customer experienced significant improvement in network latency after using our EdgeOne. This represents the efforts we have made in the intermediate layer and the original pole layer. We've introduced a concept known as farthest route assurance. You can think of it as a process where, during normal access, as shown in the diagram on the left, the customer first connects to our North American ISP. Typically, the traffic would then go to the internet to an ISP in Hong Kong before reaching the original server. Let's say how EdgeOne works. Customers' traffic, upon reaching the North American ISP network, is directed to an EdgeOne node. From there, through Direct Connect, this traffic is routed to a node in Hong Kong, where it is then handed over to the Hong Kong ISP, and finally back to the origin server. The issue addressed in this process is the stability of long-distance transmission from North America to the Asian-Pacific region. Throughout this extensive transmission distance, EdgeOne provides effective protection by utilizing its proprietary network. The following diagram illustrates the difference in transmission between routes in various regions via the internet and through EdgeOne. This mainly refers to the number of times per month the packet loss rate exceeds 3%. We can observe that the packet loss frequency of transmission via internet is significantly higher than the transmission via EdgeOne, which can almost achieve zero packet loss. Especially noticeable is the poor packet loss quality from Hong Kong to Europe, which aligns with the common perception that accessing European resources from the Asian-Pacific region often results in much lower quality and stability. Then we have implemented a strategy at the origin pole layer, which involves multiple path routing to origin servers. Between EdgeOne and Tencent Cloud nodes, we have established both physical direct connect lines and public networks. On each direct connect line, we create different tunnels based on overlay. Traffic is dynamically switched between the lines based on the quality of each line, ensuring the stability of the entire original pole process. We have made some efforts at the network level. Next, let's focus on the security measure we have in place. In the diagram, you can see that EdgeOne Edge Nodes integrates capabilities for both security and acceleration. The entire traffic processing works like this. Upon entering each edge node, the traffic first undergoes our anti-DDoS protection to filter out DDoS attacks. Following this, it proceeds to our CC protection. CC attack is a type of DDoS attack based on the HTTP protocol and possesses a significant threat to web applications. After passing through the DDoS and CC protection, the traffic is then processed to our Web Vulnerability Protection System, which effectively filters against vulnerabilities listed in the OWASP Top 10. Subsequently, it moves to our bot protection, where the attacks from crawlers on the internet are filtered out. The completion of the above 4 security measures signifies the end of the security protection phase, and the traffic then moves into the performance acceleration phase. Here, we offer a range of security capabilities, including edge functions, content acceleration, and network acceleration. Finally, the traffic is routed back to the origin server through the origin pole layer mentioned earlier. Therefore, this is the complete traffic processing workflow at each of our edge nodes. Let's take a look at the characteristics of each of our security capabilities. We can observe several aspects of our DDoS protections that I would like to share with you. The first aspect is that EdgeOne's distributed architecture results in a total capacity exceeding 15 terabytes per second, surpassing centralized architectures. In China, the largest DDoS attack in the industry does not exceed 5 terabytes per second. Therefore, the capacity of 15 terabytes per second, we are well equipped to handle any scale of DDoS attack. Our overall capacity is more than sufficient to meet these challenges. At this point, we need to consider the response time and the success rate of the protection, which is also the effectiveness of the defense. We can see that in terms of detection, we utilize Deep Packet Inspection (DPI) technology. During this stage, we can reduce the traditional detection latency of 3 to 5 minutes down to less than 3 seconds. That is, we can identify an attack and initiate traffic redirection protection within just 3 seconds, minimizing the impact on services. The third aspect is that during the protection process, we employ a variety of strategies, such as fingerprinting, intelligent database, and complex attack mitigation algorithms to effectively filter out attack traffic. This elevates the protection success rate to 99.9%. Additionally, because EdgeOne is built on a reverse proxy architecture, a small portion of bypass traffic, such as 0.1%, is directly discarded by our clusters if it does not match our conversion rules. This means that when the traffic flows to the original server, the protection of attack traffic drops to 0. We can achieve a 100% success rate in traffic cleansing in certain scenarios. The fourth aspect is stability. Even if the protection is effective, a lack of stability can still be considered a pain point. EdgeOne utilizes a network scheduling technology known as Anycast. This means that when a single node fails, we have an active detection mechanism that automatically reroutes the traffic away from the affected node. The entire process allows for rapid network convergence, enabling us to switch our services to another node within just 5 minutes. This ensures the overall stability of our nodes. Additionally, we have introduced domain name scheduling techniques. By leveraging domain names, we can address availability issues with individual nodes or clusters. This approach allows us to enhance the availability of a single node within 5 minutes. As mentioned earlier, in addition to DDoS attacks, we are facing the challenge of mitigating CC attacks. During this process, we implement 5 strategies. The first one is about CC attacks, which incapacitates web servers by overwhelming them with a massive number of HTTP requests in a short period. Therefore, it's essential to have sufficient CC protection capacity. Due to EdgeOne's edge architecture, which is different from the products like WAF, it can defend against tens of millions of CC attacks requests, far exceeding the capacity of traditional anti-DDoS, advanced, or WAF, which is at the million or even hundreds of thousands level. This makes EdgeOne highly effective against a large volume of CC attack requests. Over the past year, we achieved our highest protection success rate by defending against a CC attack that exceeded 4 million requests. This attack was targeted at a paid customer. The second is about the overall effectiveness of protection. If our capacity is sufficient, we need to identify and block network attacks by matching multiple attack characteristics to ensure comprehensive protection. Currently, we support matching based on IP HTTP parameters, TLS fingerprints, GA3 fingerprints, and more to analyze and pinpoint attack traffic. We also take various measures such as monitoring, interception, rate limiting, redefining, and JavaScript challenges. The third method involves implementing rate limiting strategies. That is, for the domains of our target customers, we can pre-configure rate limits or frequency restrictions based on source IP addresses or cookie attributes to further mitigate risks. One of the most robust protection measures worth highlighting is our intelligent defense strategy tailored for each customer. Our AI-driven automatic learning system learns about each customer's business characteristics. Following this learning, when an attack occurs, it can automatically detect any mismatches between the attack patterns and the business characteristics. Then, it filters out traffic that exhibits attack patterns. Currently, this approach stands as a highly effective method against network attacks. These are the first 4 strategies. In addition, attacks are variable. To address this, we also automatically adjust and tighten our strategies. That is, as attacks evolve, we base our adjustments on the overall health of our origin servers to automatically fine-tune the parameters of our protection measures. After implementing DDoS and CC protections, we move on to web protection. Web protection primarily focuses on safeguarding against vulnerabilities in web servers. OWASP publishes the latest vulnerabilities, their impact, and ranking annually. We mainly employ several methods to address these threats. The first is the AI Plus rule, dual engine solution to filter and mitigate attacks for known vulnerabilities. For example, we use regular expressions or intelligent semantic analysis to identify potential threats within ATP requests and intercept them accordingly. Meanwhile, we use AI to learn about our customers' business characteristics. During this process, we can further address attacks that exploit vulnerabilities outside the scope of our learning. This allows us to address unknown threats that may not have been previously identified. Before the rule engine, we have introduced a managed rule set, which incorporates over 700 protection rules to defend against currently known mainstream vulnerabilities, safeguarding the entire business server environment. For emerging zero-day vulnerabilities, we have the capacity to update our defenses within 24 hours. Next, we provide a variety of customized features to meet the diverse needs of our customers. Lastly, our web protection supports the full retention of logs, including the ability to analyze, view, and download them. This is web protection. Next, we'll discuss bot protection. In this phase, we address attacks from internet crawlers. As you can see from the diagram on the left, crawlers are divided into 2 types, friendly and malicious. Among friendly crawlers, there are those from search engines or online performance measurement tools, which we consider to be relatively benign. Therefore, there's a process of crawler identification where we need to determine whether an incoming request is from a crawler and whether it is friendly or not. We need to classify different types of crawlers and deal with them accordingly. We support a variety of approaches to crawlers. For instance, for search engine crawlers, we allow them to crawl our content by granting access. For requests that we are not entirely certain about, we initiate JavaScript challenges and use CAPTCHA mechanisms to verify whether the crawlers are intentionally malicious or not. Ultimately, we can respond differently by delaying responses, implementing silence, or defining custom response rules and content. We tailor our countermeasures to the nature of the crawlers. This is how bot protection is implemented. From what we've seen so far, our comprehensive protection process, after going through layers of defense such as DDoS, CC, WAF, and bot, have successfully intercepted various complex attacks we mentioned earlier. Moving forward, we can provide a full spectrum of security assurances for our business operations. Let's review the results of our protection. In May 2023, a customer who uses our EdgeOne was threatened with extortion by an international hacking organization. Initially, this organization sent messages demanding that the customer pay a ransom to prevent being attacked. Then the customer, having EdgeOne in place, neither agreed nor responded to the demands. The attacker initiated a 4.67 gigabytes per second attack on May 19th, which escalated continuously until the 24th. Throughout this period, they communicated with the customer while attempting to escalate the attacks. However, due to the comprehensive protection provided by EdgeOne, all attacks were successfully intercepted, thwarting the hacker's organization's plan. Since May 24th, the hacker organization has ceased the harassment. Last summer, from May to September, we assisted our customers in defending against multiple cyber attacks and threats from this organization. Regarding the capacity of our protection, in 2023, we achieved the highest global protection capacity of 2.04 terabytes per second. Within a single month, one of our customers was attacked a total of 72 times, with the peak attack reaching 2.04 terabytes per second and the average attack spike reaching 281 gigabytes per second. Throughout this period, none of our nodes engaged in traffic blocking. Instead, a full traffic cleaning was conducted, ensuring that the traffic is directed to the origin server without risk. This demonstrates our protection capacity. Thirdly, I like to talk about the application scenarios of EdgeOne in the gaming industry. As we can see, EdgeOne covers a comprehensive range of scenarios in the gaming industry. In gaming, servers are typically categorized into three types: platform servers, download servers, and matchmaking servers. Our platform server is integrated with EdgeOne through domain names. This enables all the security protection and the dynamic acceleration capabilities I mentioned earlier, providing a one-stop solution for both security and acceleration. As for download servers, the gaming industry often experiences high volumes of download traffic and significant traffic spikes. Given EdgeOne's global network of over 3,200 nodes with substantial capacity, we offer our customers download services and static acceleration services during this process. Lastly, there are the matchmaking servers. These servers often have higher requirements for latency. In this case, EdgeOne's cloud-based DDoS protection or EdgeOne's Layer 4 proxy services are used. While ensuring the quality of acceleration, we also block network attacks outside the servers, ensuring the player's gaming experience. This is an application scenario for EdgeOne. That concludes my presentation for today.